Hello, my friends. Well, this is the pre-lab video that I want you to watch before you come in to learn how to do diamond cut and proportion. Basically, what we're doing is we're trying to give you a little bit more time so that you can actually, work on the actual thing while you are in lab. So we're going to try this out, and I'm going to explain some stuff. Your TA will go over some things as well. And your TA will also take you through using the larger glass Hobby Lobby diamonds to like really quickly say, and this is this measurement, and this is this measurement. But we're going to go over all of them, and we're going to go over some of the reasoning as well. So watch this video before you go to lab for the cut and proportion on diamonds. All right, so we're going to start out with talking about why do we cut diamonds? What are we trying to do when we're cutting a diamond? We're trying to maximize how beautiful it is. We're maximizing its brilliance, its scintillation, and its fire or dispersion. So a diamond's brilliance is basically the reflections of white light. So when you move a diamond around, you get bright light showing at you, shoving into your eyes. And that's what brilliance is. Scintillation has two parts to it. One of them is the pattern of the light and dark sections when it's viewed face up. So, for example, in this picture right here, you can see that they're calling these the hearts and arrows style of doing it, where you have this very distinctive pattern of light and dark. But scintillation also refers to the sparkle. The sparkle is the play of light you see when the diamond is moved. So it's where the rose reflections of white light move when you move the diamond or when you move the light source. And then finally, you have dispersion or fire. And then we've talked about that. We talked about that in class, in lecture. But it's basically when you have white light and it goes through the prism and it goes into all of those colored flashes of the spectral rainbow. All right. So you get the flashes of red and you get the flashes of blue and yellow and things like that. And so that's what we're trying to maximize when we cut a diamond. And so you learned in class that diamonds, you learned in lab last week, I mean, or the week before that, that Tchaikovsky created what is known as the American Standard Cut. And the American Standard Cut is to maximize mathematically the perfection that you can get so that you have the best brilliance, you have the best scintillation, and you have the best dispersion or fire. And if it is cut exactly right, that's what you get. But it's not just what facets you have or where those facets are, it's also what is the proportion of the facets? What is the proportion of the crown to the pavilion? What is the height of the girdle? How thick is the girdle? And all those types of things. So it's not just how many facets there are and where the facets are, it's also talking about the proportions. And so it actually turns out that if you don't cut a diamond correctly and you get the proportions off, you see some really bizarre things. So if you cut a diamond and you make it so that the crown is way too thin compared to the pavilion. This is a shallow cut diamond, and that actually allows the light to come in through the top, but it bounces around inside and goes out through the sides. And so it's not coming back up through the crown. And so it's not hitting your eyes the way we set gemstones, where we are actually looking at the crown of the gemstone when we look at it in jewelry. If you cut it too thick, if you make it too deep of a diamond, all the light comes in, but it bounces off the bottom. And so it doesn't reflect back up. So a perfectly proportioned and well-cut diamond is actually going to have the maximum amount of light coming in through the crown, because that's where the light's going to come in, and it's going to bounce around, and then it's going to come back out, and it is going to create the maximum of that brilliance, that scintillation, and the dispersion. Just to give you some examples of this, here's a deep cut diamond. It's very dark in the middle and it does not really properly reflect out the light. Here's a shallow cut diamond, which actually is very odd looking and kind of reminds me of an eyeball. But anyway, you're not getting that pleasing pattern or the scintillation. And then here's the ideal cut where you can actually, it's a very nice mixture of dark and light. You're seeing very much symmetry and it looks very attractive. Now, just like with everything else GIA does, they have a system for cut. So cut in diamonds is graded based on how close it is to the ideal. And they have 5 different grades. It's excellent, very good, good, fair, and poor. And so in this case, this is a particular case where fair is actually usually abbreviated as F. Good is abbreviated as G, VG for very good, etc. EX is excellent. P is for poor. But an F grade is actually not the lowest grade with diamond cut, just to keep that in mind. And you can see how much of a difference cut can make for how beautiful a diamond is. Here is a poorly cut diamond, and it looks more like a piece of glass, even though it's a diamond. Here is a good cut diamond, so it's not terrible, but it's not perfect. And here is an excellent cut diamond, which has a very pleasing distribution of all the things we're looking for. So as we are trying to look at the how are we going to be able to figure out if our diamond, our little tiny diamonds that we have, are the right proportions, are the right sizes, is everything is in the right way? Well, we're actually going to start measuring things on this diamond. And yes, you're going to be measuring on those little tiny diamonds, and we're going to show you how. So basically, this is an example of a perfectly cut diamond in terms of angles, in terms of what their percentages are to each other, and things like this. So you'll be referring back and forth to this so that you can know what you're supposed to be measuring. Now, your TA is actually going to show you how to use what are known as the gauges. There's a leverage gauge and there's digital gauges. They do the same thing, but basically that is how you're going to figure out what the diameter of the diamond is. So your TA will teach you how to do that in lab. We're going to actually skip ahead. So if you, this is what your packet, your worksheet looks like. This is the part right here, diameter, and all of this stuff is going to be what your TA is going to teach you how to do. And I'm going to teach you how to do all the rest of this in this little video. And then your TA will go over it very briefly and you'll be able to get started on it. So right here we have what are known as ticks. And as we are actually learning how to do this, we're going to be looking through our microscopes, and on the left eye, there actually is what is known as a graduated ocular. Now, this graduated ocular is not to scale. This does not represent a millimeter, a mile, a centimeter, whatever it is. It's not to scale. They are simply evenly spaced lines for your microscope. And so you actually can position your diamond in those lines to be able to see how many lines a certain facet takes up. Super, super useful in figuring out proportions and estimating angles. Now, one thing you have to keep in mind, do not change your magnification once you start recording ticks. So for example, if I'm looking at a diamond through this when I'm on 2x, and then I decide I can't see things very well, so I switch to 4x. Now, all of a sudden, I am looking at that same diamond, and it is going to be twice the size that it was before. And now all of my measurements are off. So stick with one. The best one we've discovered is the 2x. The 4x is not as useful. It brings things too close, and it makes it harder. So don't change the magnification once you start recording ticks. Super important thing. The other thing that I want you to realize about this is that when you are counting these, you may count either each of the long ones, you may count each of the short ones, or you can count the long one, the short one, the long one, the short one, the long one, the short one. Doesn't matter, as long as you're always doing it the same, and the same as your partner. So decide how you're going to do it between you and your partner, and always do it the same way. The last thing I want to make sure that you guys are all aware of is there's a very common off by one error that happens. When we are counting items, we always start with one. So here's an apple, and here's one apple, two apples, three apples, four apples. I have four apples, and I start counting by one. However, when I am measuring something, I always start at 0. And this is actually really obvious, but it's actually a super common error. So for example, if I'm measuring this banana, this very small banana, I start with 0, 1, 2, 3, 4. So when you are measuring things, make sure you always start with 0, because 0 is what we use when we measure. All right, well, let me just explain how you're going to do it. You're going to position your diamond in such a way that this is what you see when you are looking through the eyepieces. You're literally going to measure across the two, like you're not going to measure up here or down here. You're going to measure across the very middle of the diamond's crown. And this is called the diameter, okay? It's the diameter of the circle. And to do this, you're going to arrange it so that you can start counting. And so if I'm going to count, let's say I'm going to count every single tick. So I would start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then I would write down the diameter is 18 ticks across. And I only need one measurement with this. We're just going to get the average measurement. So the diameter is 18 ticks across. Then I'm going to take that same position and I'm going to measure the table size. Now remember, the table is the largest facet. And in this case, you are literally going to be measuring from point to point, not from side to side. All right, so you'll measure this. And so you'll put it under there and you'll measure it and you'll say, hey, this is 11 ticks across. Then you're going to reposition your diamond. Your TA is going to show you how to use floral foam to be able to see the diamond easily. All right, so your TA will explain all of that. But you're going to set your diamond down on the side and you're going to actually measure the total depth. So the depth percentage or the total depth is from the top of the table down to the culet. So once again, 0, 1, 2, 3, et cetera, et cetera, et cetera. I get 22 ticks for mine. Now, is it going to be the same? No, of course not, because you're looking at a different diamond. You're actually doing this instead of just plopping a picture behind a circle like I have on these slides. Then you're going to do the pavilion depth. And the pavilion depth is actually from the bottom of the girdle all the way to the culet. All right, you're gonna start at the bottom of the girdle and go to the culet. And then for the crown height, you're going to go from the top of the girdle to the table. You are excluding the girdle measurement from the pavilion depth and the crown height. You're always starting at either, for the crown height, you start at the top of the girdle. For the pavilion depth, you start at the bottom of the girdle. Now, there is oftentimes a question people ask is if they can do like point, like for example, this girdle actually starts right about there. So what is that, 0.2 or something? We can't be quite that accurate. The best you can do is in between the ticks is to go about halfway. And so you would probably say that that was halfway there, and then you would start counting from there simply because we're just not quite that accurate, and you are actually introducing false accuracy when you're trying to be that precise. Hopefully that makes sense. The next set of measurements are the hardest measurements, and we have a video that you can watch that shows how to do it, and also your TAs are going to go through this part with you as well. But essentially, you are going to measure this angle right here. This is the crown angle. Through the magic of geometry, I don't know if you guys remember side angle side or something like that. We know that parallel lines that have a line going through them, actually this angle right here is the same as this angle right here. So you can actually measure this angle. And if you watch the video, you can see how that is done. And here is the video. It is on the slides. It is also linked on the website, the same website you're looking at this with, okay? The pavilion angle is somewhat similar. You're actually going to be, let's go back to that first picture. Is it going to let me? Hello. There we go. You're actually going to be measuring this angle, but sometimes it's easier to measure this one. So that's the pavilion angle. And your TA will go over how to do that with you. The next set of stuff that you're going to measure is called the star facet or the lower half facet. So just to remind you what the star facet is, this one's the star facet, this one is the lower half facet. Hopefully you know those. When you're measuring the star facet length, you're actually measuring from this point across to this point. And as you're looking at your Hobby Lobby diamond during lab, you'll be able to see that it kind of kinks out a little bit right there. And that is the thing that you are measuring. While you are measuring that, also measure your girdle to table distance because you've got it in the right place and you can see things pretty easily. When you are measuring the lower half facet, this one is one of the hardest ones to measure. It's really obnoxious, okay? It bows out just a little bit here with the lower half facet. And so what you are actually measuring is from the girdle to that little bow out. It is practically impossible to see. So our best suggestion is to go up about 1/4 of the way and measure from there. At the same time that you're measuring that, measure the very easy to see girdle to culet distance as well. Finally, you're going to measure the girdle. The first thing you're going to do is you're literally going to measure what is the girdle thickness. In this particular case, it is 1 tick, right? And then, but then you're going to look at the girdle from all positions. Okay, so you're going to want to spin your diamond around so you can see what the girdle looks like everywhere because the girdles are not always the same thickness, even on one diamond. And so you're going to actually use words and you're going to look at the place where the girdle is the thinnest and you're going to estimate that. You're going to say where it's the thinnest, it is medium, or maybe it's very thin, whatever it is you see. And then your maximum is going to be slight, whatever it is when it's the thickest. So it could be extremely thick, slightly thick, whatever. Okay, so you're going to use words to estimate the minimum and the maximum. This particular drawing can be found on in the slides. It also can be found in your on the website, the lab website, and also it can be found in a 3-ring binder in the back where it actually has all these instructions as well. Um, Once you've got that and you've written those things down, then the last thing you're going to do is estimate your culet size. And your culet size is, remember, the culet is the point of the diamond, the pointy part of the diamond, and it is the most fragile part of the diamond. But the way we set diamonds these days is we actually put them in metal and you can't even get to the culet. So originally, like in old times and antique times or vintage times, they would actually put a little facet on the bottom so it wasn't quite so fragile. But now they really don't do that anymore. Roughly half of our diamonds have a culet facet and roughly half of them don't. So as you look down through the table, you can see whether it has a culet facet or not, and then you estimate it. Once again, this is on the slides, obviously. It's also in that 3-ring binder in the back. Once you've done that, now it's time for the very easy math, okay? Don't worry, it's super easy. Let me go through an example. Next to each one of these, you actually see, so here's your table size, and this is the math you're going to do for it, okay? It's table measurement divided by total diameter measurement times 100. Let's use pavilion depth as an example. Let's say that we've measured everything with the pavilion depth. So these are the numbers we got. And now we're going to say, how do I figure out what the pavilion depth percentage is? Well, I'm going to take the pavilion depth, as it says right here, and I'm going to divide it with the total diameter. And then I'm going to multiply it by 100 because that's going to be the percentage. So it turns out that this one happens to be a repeating number. Just truncate it. It's not that big a deal. So just truncate it somewhere and then times it by 100 for your percentage. And then you would write that down. You're going to do that for each one of these. Now, sometimes they're going to be a slightly different formula. So make sure you're matching it with what is right next to it instead of just always dividing by the total diameter or something like that. Once you've got all of this, then you get to go to the GIA website. Now, at the GIA website, you're actually going to input the numbers that you have gotten. So what you'll do is you'll go to the Facetware website. Here's the web address. And you'll put this in, and you actually do have to log in. Now, they've never sent me spam to this email or anything, but you do have to log in. And so just log in, make a password, and get into it. And once you've done that, then you're actually going to change these numbers to what you got. Now, if one of these numbers, if one of these ones, the thing that you got over here doesn't match any of the numbers it lets you pick the one that is closest to it. Once you've done all of that, don't push the button. It's really annoying that there's this beautiful button right there, but it actually changes them on the fly. And if you push the button, it actually resets everything and you have to put everything back in. Okay. So what I want to do just really quick here at the end is I want to pull up the GIA Facetware website. Let me just really quickly get the, is it that one? Logged in. Yep. All right, so now I'm going to bring it over here so that you can see what I'm doing. I've already logged in. And now we can change things. So most of these, as you change them, they're not going to make that big of a difference. But I do want to show you a few things. So for example, let's just start changing this. I'm just going to randomly pick things. I'm not even doing this with very much thought. But you'll notice that down here is changing and that my grade is changing. Right now, what I've got is just a good cut diamond. So that's the middle grade, right? I can change some more things, change the girdle thickness, change the minimum and the maximum and the culet size. And so then I would write this down, and then you're done with it. One last thing to just show you how important that dang culet facet can be. Right now, we've got an absolutely 100% perfect diamond. Watch what happens when I change absolutely nothing else. Oh, I forgot to say, polish symmetry, painting and digging, leave them just the way they are. We're not going to get into those. All right, back to the culet. Okay, so the culet facet is so tiny. And if you make a mistake and make it a little too big, it absolutely tanks your grade on your diamond. For example, right now this is at a very small and it's an excellent cut. Everything else is absolutely perfect. But if I change it to say slightly large, I drop 2 full grades just for one facet, this little tiny guy. And if I go to very large, I go down to just a fair grade. And if I go to extremely large, then it becomes poor. So that's one of the reasons they stopped doing the culet facet, is because it was such a hard one to get exactly right. And it didn't seem to be necessary anymore. All right, your TAs are going to go over some of this stuff for you, but having watched this, you're going to be ready to hit the ground running and start grading your diamond in terms of cut and proportion. So I hope you have a wonderful day and week, and I will see you all later.